Hey, hello, and welcome to the show. It's me, John Park, and I am broadcasting live from the planet Mars. Today, we moved my workshop there. That was exciting. I can't believe that we landed on Mars right just a couple of minutes ago. I didn't know when that was going to happen. Figured I might have been partway through this show, but wow, that's exciting. I was telling my friend I feel pumped, and I didn't even really have anything to do with it. How y'all feeling? So over in the Discord chat, let me see some pictures if any come through. I know they're going to be starting to show some pictures of the descent over the red planet, so that's pretty exciting. All right, so let's see. You may have noticed, I don't know if you check out this blog post that goes out before this show, but I mentioned that today is going to be a very special episode because I'm going to do a build from scratch, show you a design and a build, and I'll cooking style it a bit, but I'm going to show you what it looks like to use Fritzing, the design software, electronic design software, to build a mechanical keyboard that will be controlled with a Raspberry Pi Pico microcontroller and CircuitPython using the Adafruit HID library so that we can build ourselves a keyboard. So I'm actually going to spend most of the time on that today. I'm going to skip some of my usual segments so that we have enough time to get through a bunch of stuff. I hope that's okay with you. But I have learned a bunch of things. You may know Fritzing from the breadboard diagrams that a lot of us use in our Learn guides. But you can also use it for schematics and take that all the way to PCB design, printed circuit board design, and fabrication. It'll generate the type of files you can use to make your own board if you want to etch it, or if you want to mill it out, if you have a little PCB mill, or send standardized files to a PCB house, which is what I'm going to end up doing. So not all of this is cooking show style. I'm only at the design phase, but I'm going to show you some circuit board printouts that I've done just on paper so that I can sort of verify that things should work. As much as is possible, size-wise, dimensions. But then I'll be ordering probably from Park. I'll be getting a set of 3 PCBs. I'll show you what that process looks like. And then we'll follow up when I get that in and put it together, and hopefully it all works, or I come up with some bodge wire solutions. So that's what we're going to do pretty much most of the show today. There are a couple of our usual housekeeping types of things that we'll do. I'm just checking my notes. That's why you'll hear me going, what are we doing? Here's my notes. All right, what am I doing? Okay, let's, first of all, I usually mention we have a jobs board if you're looking for work or if you're looking to hire someone. This is at jobs.adafruit.com. And if you head here, you can check out some open positions that might be freelance, might be in person, might be remote, could be part-time, contract, full-time, all varieties. It's free to post if you're looking to hire someone. It's free to use if you're looking to get a job. So go check it out at jobs.adafruit.com. It is free and will always remain free. You heard it right here. I hope that's true. I think that's true. All right, next up, I have a show on Tuesdays that you may have heard of. It's called JP's Product Pick of the Week. In it, I pick a product and I go over some of the details of the product as well as do a little demo. It's about 15 minutes long, but sometimes 15 minutes is more than someone has, and they just want to see the roughly 59-second and 23-frame version of it. So here it is, the 1-minute recap. The INA219 high-side DC voltage and current sensor in STEMMA QT format. So I'm going to run this DC motor, then we can look at the voltage and current as we run the motor. Power supply goes to the V-in, so it can measure the current voltage, and then that runs to the rest of my circuit. And now you can see it's drawing about 170 or so milliamps. So I'm going to put a finger on this motor, and as it struggles, current is quite a bit higher. It's almost double. We're running about 300 milliamps. And if I stop it entirely, you'll see we're drawing about half an amp. That's my product pick of the week. It is the INA219 DC high side current and voltage sensor in STEMMA QT format. Yes, that's it. So go check it out. I think that's still in stock. It's full price now, but during the show it's half price. So you'll usually want to tune in during that time on Tuesdays, 1 o'clock Pacific time, 4 o'clock Eastern time to see what's the product pick of the week and how do you get one for a great, giant, huge discount. That's the flavor of that. All right. Hey, you ever forget to bring water to your live stream and then just decide to see how the water that's just sitting here in your workshop is doing? Not bad, not too dusty. That's good, that's a gamble. Sometimes that doesn't work out well. All right, let's see. Let's get into this thing. Right, so first of all, what are we talking about here? I'm gonna grab one of these here Picos. And I'm gonna grab, so that's the Pico microcontroller right there. It's a Raspberry Pi designed board with a Raspberry Pi designed chip. The RP2040 has dual Cortex M0 cores in it. It has a lot of really tremendous features, but it's also only $4, so I don't feel bad using it for something that's dead simple. The reason that this is a good fit for doing a keyboard, so this is going to be a USB keyboard, like a keypad that you might have, a little 10-key keypad off to the side. I'm actually going to build it, I think, with 21 keys. And I'll talk about that number in a second because my friend Steve, who's watching, has a 21-key keyboard that he made that's sort of like a music keyboard, a MIDI type of thing. Mine is not that. It just turned out that 21 worked to be a good number for the design that I came up with. But one of the reasons it's easy to do on the Pico is if you look at this little Pico pinout that we have right here, you'll notice there are a lot of these pins that are labeled in yellow. Those are the general purpose input-output, or GPIO pins, and there are, I believe, 27 usable ones. There's one GP15 that's a little tricky to use because of its involvement currently with the USB reset function. So I won't touch that one, but we've actually got essentially 27 general purpose I/O switches or input-output pins that we can use. And so if you take the board here, and I'm going to just plug a wire into one of the ground switches. There's a few grounds around there. Right now, this is going to act like a USB keyboard. I've actually coded it. It's not plugged in, but I've coded it so that when I press that, it's going to press a USB key. I think this is the letter K gets pressed when I touch that one. I'll show you the code in a minute. So if we consider the fact that it has that many GPIO pins, it means that we can connect up some of these key switches. That's what's inside of a mechanical keyboard that you type with on your computer. It has this type of switch in it generally. This is the most popular style and design, called a Cherry MX switch. There are others. I don't want to start a holy war there, but this is similar to what I'm going to use. I'm actually going to use the black ones. They're a little stiffer and it'll work well for my needs. But you'll see on the bottom of that thing, it's just, in fact, let me go to a, why am I showing it up there? Let me go to this view. Hey, look, I've got a nice big camera view. So you can see here this key switch has 2 pins. If you press this down when you type, you've just closed that circuit. And so running any of these GPIO pins to ground, which is little square pads here, will in effect press the button. And I'm going to show you, let's take a look real quick at some of the code here. I'll come back, hey. So this is just some generic example code that we use for doing HID stuff. Let me find my Atom session. So you can see here, I've just adapted it a tiny bit for use on the Pico. I'll be writing something a little more fully featured that will make it easier to establish a key mapping of these 21 keys that I'm going to have. But you can see here, the essence of this is that we bring in digital I/O, which allows us to use input-output on the pins. Output being things like you want to light up an LED, input meaning we're going to press a button. And I'm bringing in USB HID and the Adafruit HID keyboard and key code libraries. And this makes it very easy to press the USB keys that are on a keyboard from within code. Next thing I like to do this is set up the little LED that's on the Pico. In fact, let me plug this in for you for a second. How about, we'll do this type of view here, here and here. Oh, close, I almost got it. There we go. So you'll see there's a little LED here that I like to have that turn on when I give it power, just so I know that something's happening. And I also have it, I'm not going to press it now because I'll screw something up, but if I did short that, that first or second pin right now, it's gonna blink once or twice when I press it, again, just as a little bit of feedback for me. So that's why I have this set up here where it says def blink number of times. So this is a function that I call the blink function. So if I type in blink parentheses 1, it's going to blink that one time, and this is how it does it, by just setting the LED's value false, pause a little tiny fraction of a second, and then turn it on. So it always stays on. You'll see it blink off when I blink. All right, the next thing we do is we bring in the keyboard. We create the keyboard device on USB HID. And then this was, in our sample code, there were a couple of, just 2 buttons, and one was essentially Alt-Tab, switching between apps, so it was called the swap, and this one was called the search, and it's the Control-K, which I think brings up the search in a web browser. So these can be changed. The GP0 is the first pin here on the Pico, and GP1 is the next one. So considering this key map here, you'll go through and decide who's connected to what, which is what we're going to be doing when we get to the PCB design part of this. And then we have a little, this is what runs the bulk of the program, is just waiting for those keys to get pressed. And when they do get pressed, it sends the keyboard command, either a single key. So down here, I've changed this one to just send the letter K, key code K. If I wanted that to be a capital K, it would be key code dot shift, comma, key code K, so that holds the shift and the key code. We can also do things like repeats and do different things when we release, press and release, so there's some sophistication to what we can do, but this is the basic example of this. So let me, now let's talk about how you can design your own keyboard, because this is something that if you've ever looked into the mechanical keyboard world, that's not just buying them, but the hobby of collecting them and lubing your switches, it's not as dirty as it sounds, buying custom keycaps, fancy resin keycaps for your escape key, and so on. There's a whole world of this hobby of mechanical keyboards. And one facet of it is making your own custom keyboards that aren't just a typical layout. So there's sort of the 101 key layout, there's 80%, 70, 60, 40%, there's ortholinears. So there's a lot in the keyboard world. Some things that you may be familiar with, in fact, let me dangerously unplug my camera switcher right now. This is a similar type of thing that I made from a PCB that Andy Clymer designed, and it's a trinket under there and a little diode matrix for these 6 keys, and it sends out USB HID. I use that for switching my cameras in the program I'm using while I'm doing this show. And another example is this one I've shown before that our friend of Adafruit, Steve Noreko, made. This is a beta or a prototype of a MIDI keyboard that can be used like the black and white keys on a piano keyboard, but it can also be a sequencer. And again, these are mechanical key switches in a PCB with some keycaps on them. This one's fancy because it has underlighting, RGB underlighting, so you can indicate things based on the lighting. And here's a project, another one from Steve, that's going to be, I think it's a Itsy Bitsy based, Itsy Bitsy M0 based keyboards, macro keyboard that'll have 10 key switches on it. And we're gonna care about these little patterns of these footprints of the keys in a second when we get into the design. So you can, of course, just use any button or switch that you want, but we're going to do this specifically with key switches in mind. So what I'll do is let's pop over to Fritzing. So Fritzing is the design software that we use to create, let me bring my camera view back up, that we use to create the schematics that you see in most tutorials. So you can see it's got this very user-friendly design of the familiar breadboards, and we can drag wires between things to create connections. So I'm going to actually not use a breadboard in this case, but what I'm going to do is I'm going to wire it up to a Cherry MX key switch. So first of all, in Fritzing, you'll need a object for this Pico, and that is available on the Raspberry Pi site. One nuance of it is that I was searching around for Fritzing elements or Fritzing objects for the Pico and found a discussion. In fact, let me pull this up here. Over on the Fritzing, there we go, over on the Fritzing forums, and someone said, looking for Raspberry Pi Pico part. There's a discussion here. Van Epp, who I believe is one of the maintainers of Fritzing, started building one, and there's a long discussion here about doing the castellated pads as surface mount versus through hole. Van Epp, in the end, creates a both. So there's an option to use. If you look back at our down cam here, you can see this has these castellated pads, which means it's fairly easy to, let me grab a proto board here to show you an example. It's fairly easy to solder this like a surface mount component. So let's say this is a PCB that we wanted to use. You can have pads instead of holes. So this is not a great example, but if we have pads here, you can heat the solder to connect without putting header pins down, which allows it to be a simpler design, and it's a little bit easier to design the total board with this in mind. It's also lower profile, so you can keep things small. And you can also do like cutouts and sandwich them in and make them flat with the boards. There's a lot of cool stuff you can do with that. So in this thread, and I'll eventually be putting together a guide on how to design your own keyboard from scratch inside of Fritzing, because a lot of people will do this inside of Eagle and KiCad or KiCad or however you say it. And absolutely, those are fantastic. They're also much more sophisticated and have a steeper learning curve. And a lot of people, I think, start and stop inside of Fritzing just with the breadboarding section of it. But what I wanted to do is take it all the way through to the end where you can get your board manufactured. So this link I'll put up in the end here. We end up with a couple of links to some boards, and I think one of these ends up becoming the official one that Raspberry Pi is using, that Alistair Allen has posted up there. So that's a little bit of the story behind that part. The Cherry MX switch, I think it's just default in Fritzing. So if we go back to Fritzing here and head up to the search, you can type in just Cherry or I think key switch, and it comes up with this object here. It doesn't have a pretty breadboard view, but it has everything we need in the schematic view and the PCB view to do what we're going to do. So if we were, I'm laughing because in the Discord now a Weisenheimer has said it's pronounced KiCad. Thank you, Todd. The schematic view here, if I switch over to this, shows us the object, the Raspberry Pi Pico object, and the switch object, and all of their pins. And so what I'm going to do, I just happen to know that the pin 2 on the switch is going to go to ground, and the pin 4 is going to go to the digital I/O pin. And I'll verify that. Let me cheat for a second and look at my other one, because there's a lot of pins on this that aren't used or are used if you're doing things like lighting up LEDs. Some key switches have those integrated. So let me double check. Where's my other Fritzing here? Yes, that's the pattern we're going to use. So just to start this off, the simplest one, this would be the Pico with one key switch. We will run from pin 2 to ground, and on this Pico, all of the pins that are squared off at the end are ground, which is really helpful. Since there isn't a silk screen indicator on the top of the board, it's really helpful to know that those are squared off, especially when you're in here. And then let's say we're going to just connect that to pin 1, GPIO 0. And what I'll do is make some curvy lines there just so that it gets out of the way. And I'll color code these. How about yellow for this signal and black for ground? Okay, and by the way, I got to be mindful of the time because Scott is going to do a deep dive at 2:05, so I got to be out of here at 2. So someone yell at me if I'm going long. So now if we look at the schematic for this, what we see is the switch has all of these pins available, but the two that I picked there are the pin 2 ground and pin 4 for the signal. And what you can do here is you can start to lay this out in a way that makes it a little easier to look at, especially when we end up getting a whole mess of switches on there. You can also get some more sophisticated and create little sort of remote networks, little net labels that allow you to separate things visibly, even though they're still connected under the hood. But for this, I'm going to leave everything visible so that it's easier to follow. And so, again, I'll not even bring in ground elements, which you often do. I'm just going to leave this directly connected. And what I'll do is I'll take this net line that's dotted, and I will sort of stamp it into existence by dragging anywhere on the line. That'll also add a bend point, which can be useful for arranging things. So you can see everywhere I click on here, I can move one of these little lines around here. So there's also some grid snapping that's not going to be perfect because this part isn't the size of the grid, but I'll live with that. So what this means now, since I don't see any dotted lines, and down at the bottom of Fritzing, let me see, can you see that? Yeah, down at the bottom you'll see in red here it says routing completed. So there are no connections that we specified over in breadboard view that have not now been taken care of inside of the schematic view. And you can also auto route that, which would work fine for a simple example like this, but as you get more objects, you tend to want to route them by hand yourself. So now what we'll do is we'll head over to PCB view. And so you can see here, the cool thing is that there's a breadboard view, a schematic view, and a PCB footprint available for both of these parts. And what I'll do is I'm going to start physically arranging them the way I want them in the real world. So first thing I'll do is I'm going to rotate this Pico 90 degrees, and I'm just going to make sure that the USB connector is flush with the top or even protruding a little bit from the top, and that's just to prevent a cable from bumping in. You'll also notice there are labels associated with objects, and sometimes those don't say what you want, and sometimes they're not oriented the way you want, and you can fix all that. So what I'll do is, let me see, I'm missing some elements. I'm going to open up the inspector and the layers over here on the right. So if I look at the inspector for this part, it says this is the version 4 of the Raspberry Pi.org Pico. They're calling it Mod 1. I'm not sure why, but I'm going to call it Pico. And if I rename it in the inspector, that renames it here. Also, the little element can be rotated separately from the object itself. So I'm going to rotate that 90 degrees, and maybe we'll put that somewhere on the breadboard or on the PCB that we'll see. So now you'll see what we have is this is a gray, this gray background is the board itself, and we can drag its corners around to change its dimensions. Unfortunately, inside of Fritzing, we can't give it an irregular shape or round the corners or anything like that that you might be familiar with in other CAD software. There are hacks, there are workarounds where you can go in and edit SVG files, but we're going to live with this square or rectangle, and that'll actually work fine for what I'm doing. And now what I can do is I can move the key switch footprint where I want it. So let's say we're making a little 3-key switch, tiny little keypad. Maybe this is all we need. Maybe 3 of those, one on top of the other would work. And again, same thing. This has a footprint. It also has this silkscreen object that is the name of the switch, which will get silkscreened onto the circuit board. And I should mention, if I look at this example here, so this is what's my camera switcher. That's the circuit board that my camera switcher uses. If I put this under the overhead here for a second, you can see this here is the silk screen, this outline of the part, and the name, Andy Clymer, Adafruit Trinket M0. All that is what the silk screen is going to end up being. This was done on a fancy black matte finish board, which is cool. But you can see it's nice to have these outlines printed. These are really elaborate key switch footprints because they accommodate a whole bunch of different standards. So there are different manufacturers of key switches that have different positions of the pins on the bottom. So this mess here is to accommodate that, as well as rotary encoders. So this is more elaborate than we're going to get. Another thing you'll notice is that this board has a diode per switch, because this works as a row and column matrix, and the diodes are necessary to prevent key press ghosting. We are actually not going to need any diodes on ours because the Pico is so full of GPIO. It has so many available pins that for this project we don't need them. Of course you could, and that would be more efficient, and it would leave those pins available for all kinds of other things, but I'm gonna keep it simple. Oh, Adam over in the Discord said that they made a Cherry breakout board last year. Very cool. Breaking out all those bunch of little pins you see on there, so you can plug them into a breadboard. Very cool. So if I come back to Fritzing, let's now, once again, you can see we're faced with the dotted lines, which these are called the rat's nest wires, and these have not yet been connected. So it's telling me, essentially, I specified in breadboard and schematic view that I wanted to make connections. They have not yet been made with copper traces, which is what we'll get. So circuit board starts as a piece of fiberglass board with copper cladding on typically two sides, and then it gets milled away, cut away, etched away anywhere you don't want copper traces. So a very simple way to deal with this is just like we did before. If I go and touch or drag a rat's nest line, it will create for us a trace. However, you'll notice there's a couple issues going on here. For one thing, it doesn't care that I just bridged this hole, which I may not. There's a connector there, which I may not want to bridge. So it'll let you do whatever you tell it to do. So I maybe want to move this up and out of the way a bit. And same thing, you can see it was crossing this pad right here, which was going to be bad. It means we would have bridged that GPIO pin with, I think, the 5-volt pin on the Pico. Let me consult my chart. The V bus, so voltage bus. So that would have been bad. So we don't want that. And there's also a few things happening here that I didn't really check on that I want to discuss. Oh, look, I can get rid of this bend point here and just run this straight over here. And that is, what side are we actually putting our traces on? What I'll do is I'll actually undo a couple. There we go. So I'm going to get rid of that one. And I'll show you down at the bottom, and I'll say, if you're used to Eagle, which I use it a little bit and have made a few boards on it, so I kind of learn it and then forget it and learn it a few times a year. But especially if you're an expert in Eagle, you, of course, stick with Eagle. It's amazing. But one thing I've noticed is that this thing, Fritzing, is really user-friendly and has distilled down to the essence of what you want to do, making it pretty obvious and pretty easy to do things if you're doing not super sophisticated stuff. It doesn't have crazy auto routing and pushing and things like that. So right now, what layer am I drawing my traces on? It's actually just these big buttons down at the bottom. There's a couple of these you use a lot, which is the view. Am I looking above or am I looking below? And that flips your camera view to underneath the board. You can see it's mirrored or it's backwards because we're under there. So I'll go back to the top of the board. So this is the, hey, what side am I looking at? And then there's the, which side am I drawing on? And so I can draw on the bottom layer, I can draw on the top layer, I can draw on both. I'm not sure how you specify then. I guess it's if you pick a point. So the first one I created there, I think that's going to connect to a drill hole because it's the Pico sitting on top of the circuit board, but it has made essentially a via to poke through the board and then connect underneath sort of automatically, which is really nice. And now if I want to create the other trace on the top of the board for whatever reason, usually it's because you're avoiding shorting and crossing things. So what I'll do is I'll switch, I'm now on the top layer, and if I grab this GPIO 1 pad and drag that onto the switch, and now I'll kind of move some things out of the way again like I did before, just so it fits nicely. Not bad. I actually probably shouldn't do it up here because there's some parts from the USB the USB micro switch that could potentially scratch away your solder mask and create a short. So that's not a super smart place to put that. But I just wanted to show, for example, that that's how easy it is to pick which layer you're placing things on. And at this point, let's say that I love it. I'm done. I want to go ahead and have this manufactured. So there are a couple things you can do at this point. One is have it check some design rules to see if your board is actually proper, if it can be manufactured. So in Fritzing, there's a menu. You're not seeing me go to this, but I'm going to go up to a menu under routing that says design rules check. It says your sketch is ready for production. There are no connections or traces that overlap or are too close together. So you didn't see that pop up, I think, because it's a separate window. So it was happy with me. If I do this, if I move my trace, let's see if it catches that error. So I'm going to run that again, design rules check. Yeah, so it lit that up red and said, this is bad. This is an area that's overlapping that you don't want. So this is a step that you'll typically do in order to make sure things are good and safe and copacetic. So what I want to do now is actually jump ahead to the design I did where I added in the full set of switches. But before I do that, let's take a look. I'm going to head over to the overhead view, and I'll show you kind of what my design in my head looked like, and then I started rearranging some keycaps to kind of lay it out. So let's go to the bench cam here, and let me see if my one camera overheated over here, so I'm going to try to power that back up and see if it's happy. And I will open the back of it to let some air through. One second, I'm just focusing. That should be good. You'll let me know. All right. Let me bring that up in the corner. How about main view there? Sure, that'll work. Okay, so let me zoom this way in. Here was my, I'll grab a different Pico. Here was my original, or what I landed on anyway. Sorry, that view is kind of dark there. Is that in focus? That is not. There we go, that's better. Brighten it up too. So this was what I came up with. I've got these really cool sort of retro keycaps, and they fit really nice together on a grid rather than staggered like this type of arrangement here. So I wanted to create something that I can use as a shortcut for video editing of buttons. So I've got my shuttle control that I can hit play and rewind and so on. But there are edit controls like insert point, out points, cutting, maybe I'm switching between color layers, RGB. This is just a mock-up, any key can go on these. I also have this one, I've got some blanks on here. There's also a two key wide blank that I can place on top of two keycaps and just pretend it's a single button, or I can swap that out for two. So this is pretty versatile. I also liked that it was the same height as the Pico. And that seems like enough to do a lot. It makes it a little different from a 10 key or a 3x3 or a 4x4. So this feels good. It's a good size for your hand, I think, for getting a few keys without moving around too much while you're editing something. And it could be used for Photoshop, could be used for 3D software, could be used for music software. So I feel like that's kind of a cool arrangement. So that's what I wanted to do. So what I came up with over in Fritzing, if I jump back here, let's see, give me a moment. Where's the other Fritzing? There it is. Okay. So now it gets a little crowded in the breadboard view. But all I've done is duplicate that same sort of idea. So I have the MX switch. I have the grounds all running to each other off of 3 points on the Pico. They could all just be on a single sort of daisy chain. And I don't mind that this is a bit of a mess because I'm actually not using this to share how something is built. I'm just using it to lay things out so that I can go into the schematic view and make sure everything is lined up properly and then go in and build the PCB. You'll also notice I added, this is something I'm doing on Pico projects now, I added a reset button. So pin, I believe 30 on the board right here is called Run on the Raspberry Pi chart. It might say that on the back of the board. Does it? I can't see it. It's so small. Yeah, you hear me complaining about the size, or not having the pin out on the top, but I can't read it anyway. It's so small. But Phil B put that as reset, which I appreciate, on his little pin out chart. You can download that on the Pico page on Adafruit. And that just gives me a button to press when I want to reset the board, which you do. Sometimes you have to double click it to go to bootloader, or sometimes you just want to hit reset. So. I am so sorry about that. I think that was batteries dying, and I'm so sorry I just blew everyone's ears away with that. I wish that this system were smarter about what it does when the transmitter has battery problem. Looks like the receiver is still good, so that shouldn't happen again. I'm so sorry about that. All right, we're back. So anyway, I was saying I like to set up this little reset button, so that's the one addition to this. If we head over to the schematic view, I tried to at least give myself enough space so that things are not on top of each other, but this is usually the type of case where you would end up adding little net labels and connecting things. I can show you what those look like in a second. Let me open up this here. Let's go scrolling up and go to core. That's where I need. Down to these little guys, little net labels. This allows you to call, it's like a virtual plug, a little wireless plug between things. So you can set your switches over here and plug them into, through midair to the neighboring net label that has the same network name. So you could do that to neaten things up here, and that's something that people are pretty familiar with if they're using other CAD software and making more sophisticated circuits. But here we can get away with this. And so I've labeled and numbered my switches essentially 1 through 21, starting in the upper left and moving my way down and around the board like so. And you can see here I have, in a few cases, to avoid making a mess with all of the ground pins, not only am I running them sort of in series among the switches, but I've also got little ground network labels that I can connect things to without having to connect them in space. And so here, let's get to the PCB. So same process we had before. I'm going to turn off a bunch of layers and bring them on to tell you what we're looking at. So here is the board. Let's bring on the silk screen top layer. So those are the Pico, the little reset button I have over here, a little micro switch, and the drill hole for the bottom side of that cherry switch. So you see it's got that little post that goes into the PCB. This is actually a silkscreen drawing around that hole, and then the hole, let's see, I think that shows up with, let's find it, something has it. Silkscreen bottom, silkscreen top. Yeah, I think maybe it'll only show up when it gets cut through some copper, so I'll show you that in a second. One thing you'll notice when you're designing with this board, if you're doing it surface mount flat like I'm doing, you have to be aware that there are some traces right on the bottom. You see those little programming pins, little traces there? We don't want those to short anything, and that's why the part has this keep out listed here. So I actually bring in a part called a keep out, and if I, let's see, if I bring in my copper top layer, you'll see it. So this is where I've indicated I don't want any copper to get filled. I don't want any traces to go around across that. So I think if you used the auto router, it would route around that, and I manually routed around that myself. And let's see what else. So you'll see here now I've got the copper turned on. All these pads that come with the footprint have shown up. I actually may make a new version of this footprint that is just the 2 pins I need and the hole, just because it's going to make routing it so much easier, and go back and do a very specific one. Most of the switches I deal with don't have the LED. I know people get mad at me because they want the options, but it would be kind of nice to make a very elegant version of this that doesn't have that. Oh, something got moved. How did that happen? Did I bump something? Did you see me bump something? What is this? Or did I put an extra switch out here as a demonstration? Let me zoom out. Yeah, this little switch that's not connected to anything just showed up in my PCB view to ruin the party, so let me get rid of that. Adam asks, why not wire the keys as a matrix in order to free up some pins? Mostly because I just wanted to do it the simplest, easiest way possible for a beginner without dealing with the matrix, without dealing with that code, without dealing with the diodes, and to show off the fact that the Pico for $4, just use all the pins. Like there's, my time is, everyone's time is money. So for me, just making this saying, look, it's a $4 board that has 21 pins, I'm just going to wire to them directly. There's absolutely nothing wrong with doing it as a matrix. It's the smarter way. It's the right way. I just kind of didn't feel like it. So hope that answers the question. Maybe I should do that version too. It'd be kind of cool to do a matrix one. And then that allows you to go create, gosh, I'm sure you could do 100 keys if you wanted to, if you're using the matrix on this board. And if people don't know, a matrix is where there are just a few pins used, but they are scanned in columns and rows with timing. And so the timing is so fast it feels like it's always checking. And it allows you to run through a whole bunch of keys, which is how all keyboards actually do this. All right, so that is the copper of the parts, the copper of the pads that come in with this surface mount version of the Pico. And then what I did is I started to create traces and vias. So vias are those holes that allow us to go from something that's on the top of the board through to the bottom and then continue on. So you can see I took a bunch of the keys here that are on this side of the board across the top side of the board. And then if I show the bottom copper traces, those are that orange, so it gives you the yellowish for the top and orange for the bottom. Those are actually, they seemingly right on top of each other, but that's because some of those are on top of the board and some of those are on the bottom of the board. Since we're using this surface mount part, we actually use these vias to go underneath. By the way, I may be underestimating this part. It may automatically do that when you make a connection to the bottom, so I'll definitely check that out and revisit this. Because I think the part was really smartly made, and it may just do that for you, and I may have done a bunch of extra work by creating these vias. But that's what allows me to shoot from the top to the bottom and across without getting in the way of traces. And this is the best I was able to do in a short amount of time of hand tracing this. It's not as elegant as some software that lets you like snap to angles and make chamfered edges and things like that, chamfered corners. But it, I think, is actually manufacturable and will work. So what my next step was is to, you'll notice I have none of the ground pins connected right now. And if I turn on the rat's nest layer, you'll see this light blue show up. Those are all the ground pins saying, hey, we are in dotted lineville. We don't have any connections and we should. So what I did for that is I created a ground plane. So it allows you to specify the top or the bottom or both sides of the board. You seed one point. So this is kind of cool. You pick any of your ground pins on the board. I'm going to use one of the ones on the Pico. You right click and you say set ground fill seed. And so that gives it the idea of what the ground fill network is. And then you go up to, I don't think you'll see it here, but if I go up to the main menu, routing, ground fill top, ground fill bottom, ground fill both. So I'm doing just the bottom layer, and I've already done that, so I'll show it. When I add that copper fill on the bottom layer, it creates essentially the full original plane of copper with just some parts drilled away or cut away where we need it for traces, but all of the ground connections. In fact, I'm going to flip to the bottom view and just show you. So this was one of the pins of my key switch. It is now connected to ground. You can see these other guys are islanded. They're not connected to ground, but this one is, with this little kind of cross shape that gets made there. So the copper fill does that for us. It means that I'm not doing a whole bunch of extra traces to get around. It's just anywhere we need ground, we've got it now, and nothing got abandoned, which was nice. And you can see I've also put like a little logo there. You can put a BMP. You can mirror it if it's going to be on the bottom. That'll be on the silk screen. So let's see. I've still got enough time. So let me show you what happens next. Let me switch to the bench cam again. And how about that one there? So I went ahead and exported. I'll show you in a second how you do that. I exported those files as PDFs, and then I printed them. I printed the copper layer of the top, and I mounted it to some hardboard, and the bottom. So you can see it's got that big. It's almost all copper. It just drills away where we don't need it. And that allows me to, again, do a sort of reality check. I even used a hole punch to start popping things out so I could lay a switch in there sort of flat. I still got some other holes that need to come out. But that allows you to look and see, does everything really fit on there? If I take the Pico, this is one that has headers on it that I won't really use, but if I take the Pico and set it on there, does everything seem to line up? And that's what I did. You can see if I sweep these guys away here, that's what I did originally, just with the part placement before I had done the traces. But then you can go ahead and swap that in for the one that's going to show you the final board. Also useful once you start doing mechanical design, because there's typically a layer of either PCB material or metal or plastic or acrylic that will be used to hold the switches in place. You can see on Steve's board here, there's some acrylic, actually there's PCB rather. There's an acrylic spacer, but there's PCB that the key switches are snapped into. You can see it here too. I've taken apart a keyboard, and these are the kind of two layers that matter. You have the PCB that all those key switches are soldered to, and you'll see those look pretty familiar, same design. And then the top layer, all those keys snap into this plate of metal on this one. Is that metal? No, it's plastic. So that step is really helpful. You can check do a little reality check that everything seems like it is what you thought and everything will fit into space properly. And now let's jump back to Fritzing for a second here. So in Fritzing, you can do this export for PCB. So if I click on that, we can do a PDF file, which is what I printed there. You could also use that for etching. If you're doing an etch-resist chemical process, you can use that PDF and print it onto some toner transfer paper. You can make an SVG file, and you can send out a Gerber. So what I did, let me open up my Finder view. What I did was I exported the Gerber, and these are the layers that it gave me: the contour, which is the shape of the board, copper bottom, copper top, a drill template, so that's coordinates. I think it's like a XML file maybe, that shows you, no, it's like almost like a machine code, G code kind of thing that just tells the drill where to go and what size to be to drill out all those holes. I took all of these files and I zipped them up into a Gerber.zip file, which is actually what some software, CAD software, or fabrication houses want to import. There's solder masks for top and bottom, paste masks. If you're doing pick and place, there's a file here about that. I'm not going to be bothering with that. Silk bottom, silk top. So now here's the cool part. What I'm going to do is I'll head to this browser, and I'm going to go to OshPark. So OshPark is a PCB manufacturer house that lets you do quick turnaround, low volume orders. And on here, you just click on this Browse for Files, and I'll go to that Gerber.zip file that I created. Oh, that's my PDF directory. Hold on. Gerber. And get that Gerber.zip. This will now, on the back end, they're going to ingest that and pull it apart and figure out what layers things exist on. There's some standardized naming, I believe, is how it's done. But it might be headers, too. Probably is headers. And this will now, they've kind of verified that this can work. They aren't throwing up any warnings to me that I have drills going through traces or anything like that. They check for some stuff like that. And they tell me it's going to cost $83.25 to get 3 of them. So there's always a 3-board minimum. But that's not bad. That turns out to about $28 for one of these. And then you can give them to a friend or sell them if you're making just a few and you only need one. And now if I hit on continue, this is the exciting part, because they give you these nice previews of your board. So here's what the top will look like. I can get this pretty big in view here. And then you can go through here and verify the design. There's the board bottom. It looks good to me, and it looks real. Isn't that fun how it starts to look like a real thing? Gives me the drill holes. Silk screen on top. So there's the top layer traces without the solder mask on top, so you can look at those. And these are pretty big. You can zoom in really close on the PNG file to look at it and see if it's what you hoped and thought it would be. And here's what the bottom layer looks like. So remember I mentioned that copper fill. You can see all these little plus signs. That's where the ground pins are connected. You want to look at little stuff like this to make sure that nothing's touching where it shouldn't. It looks good. That's probably a via. So that's got copper, but then it's going to get a drill hole through it. Different masks, silk, bottom silk. This one will be mirrored, and they tell you that. They have a nice little friendly description, so they tell you what to expect and what you should be seeing. But this one here shows me, for things like those vias, they've got copper, but then they've got drill, so those should work just fine. And that's pretty much it. At this point, you can go down and place your order for these. Hit order. This is not an ad for OshPark, by the way. It's just how I'm probably going to get these so I can get them quick and continue this build. You can also, if you need them really fast, you can hit this super swift service. This one says it ships in 4 to 5 business days, 4 to 7 calendar days. If you go to super swift, let's see, does it say? It doesn't say on there, but I think that tends to get it in half the time or something like that. So I've only done that once or twice, but reason being you can't do the After Dark, which is the cool black fiberglass substrate. I usually do that, and that one doesn't have the Swift service. But yeah, that'll double the cost. So now you're talking about like $50 a board, so Probably only if you're doing it for your live stream and need to get it real quick would you do that, or you have a client, you're impatient, whatever. There's lots of good reasons to do it fast. A lot of other great PCB houses, JLPCB, PCBWay. I'm not trying to play a favorite here. I think used Osh Park more than any other place, but I just do these kind of little one-offs. So that's the process. Let me know if you have questions. People in the Discord chat are talking about the viewers that exist out there for Gerber viewers. Steve, okay, you're on. He's the one who made that keyboard I keep showing, this little guy. Here, he does nice work. He has good suggestions. Says that there's a circuitpeople.com as a Gerber viewer if you want to inspect your files. Oh, that's cool. Some talk about diodes from Jeff. You don't need the diodes if you have the 1 key per I/O thing, so it's simplifying, but you can't do a full keyboard. Yes, for sure. Oh no, yeah, so Todd said the Fritzing menus weren't showing up as part of the stream, so go play with it yourself. I think Fritzing is $5 or $20, somewhere in there. Maybe it's still free also. I think I paid some money in the last year for it, but I can't remember why. Or what was going on with that. I think it might be free. Who knows? Go check it out. It's very cheap. Pretty low learning curve. So you can get into it and make yourself, maybe just make like a little 3-button keypad. The smaller the board is, the cheaper. So if you made something that was just twice as wide as the Pico and just had 3 keys on it, it'd probably be $8 a board or $5 a board, something like that. So I think that's it. Thank you so much for sitting through this very special edition of John Park's Workshop, where we built a thing and we'll continue to build it from scratch. By the way, I'll check out over in the YouTube chat. Sorry, I didn't check it out before. There's Scott Shawcroft saying hi, and Scott's got a show right after this. At 2:05, he's going to be doing a deep dive, so make sure you go check that out. Hugo, thank you. Hugo Dahl says he thinks it's an $8 donation for a download, but there are also free avenues like software package managers. Okay, so yeah, if you want to get to the nice, easy, all-in-one download installer page, there's a suggested donation there of $8. All right, that's going to do it. So I will see you next time, and maybe I'll even have a circuit board ready at that point. Thank you, Hugo, for saying fritzing.org. That's where you want to go to check that out. And that's also thank you, and go check out Scott's live stream next. That's going to do it for me. I'm John Park. This has been John Park's Workshop. Bye-bye.